Okay.
Good morning, everybody. Today is 8th December 2020. The day is Wednesday, and my name is Ferhan Mazher. And right now, I am with the 11th Cambridge class. The subject we are studying is Physics 5054. And this is the second part of today's lesson with the 11th Cambridge. And we are working on October, November 2018 2-1 paper. It's a theory paper. We call it paper 2. And we are working on a section B. We, in our last lecture, we have done with the question number 8. That was the first question in the section B of this paper. And now we have started working on the question number 9. So on your screen, question number 9 is showing some waves are longitudinal and some waves are transverse. State how a longitudinal wave differs from a transverse wave. You see, you only have to mention a few. He did not mention it because this is a 1 mark question, so we need to mention one difference. But I can tell you more than one difference. You see, in the longitudinal waves, the particles of the medium, they vibrate parallel to the direction of the propagation of the wave. While in transverse waves, the particles of the medium vibrate perpendicular to the direction of the propagation of the wave. This is one difference. Another difference can be the longitudinal waves consist of compressions and rarefactions, whereas the transverse wave consists of crusts and troughs. So you can write these differences. Let me show you the marking scheme also. Yes. On your screen, the marking scheme is showing. This is the A part. Okay. Write the answer, then we will hear what you have written. Kusam, when you have written your answer, kindly let us know.
Sir, I'm done. सर मैंने
Yes,
लिखा
what
है
you have written?
इन longitudinal in longitudinal wave particles vibrate parallel to direction of propagation of wave while in transverse wave particles vibrate perpendicular to direction of propagation of wave.
Yes. Achha, particles of the medium. You said particles only. So, but the more clear wording will be particles of the medium. Understand?
Yes.
Okay.
Next part.
Next part. Okay. A vibrating rod produces a water wave in ripple tank. Figure 9.1 shows the crest of the wave passing into the right hand section of the tank where the depth of the water is different from the depth in the rest of the water. So the arrows in the figure 9.1 shows the direction of the travel of the wave in the two sections of the ripple tank. In the left hand section of the tank, the wavelength of the water is 0.0 0.019 meter and it travels at 0.17 meter per second. Calculate the frequency of the wave. If you want to find out the frequency of the wave, the formula is very simple. You see, the famous formula, V velocity is equals to frequency multiply wavelength. Okay?
8.94.
You are done with this thing.
Yes.
So if you want to find out the frequency will be velocity divided by wavelength. So velocity is 0.17 divided 0.019 meter, and you are saying the answer is how much?
8.9.
Hertz.
Yes.
Write the unit also, bete. Write the unit also.
I have written.
Okay. Then it says state what happens to the frequency of the wave as it passes into the right hand section of the tank. Remember, when the water waves will move from the deep water into shallow water, the frequency will not change. So it will remain unchanged.
Next.
The third part is using the figure 9.1. State and explain what happens to the speed of the wave as it passes into the right hand section of the tank. So try to understand. You see, when
Speed
this enters
increases.
in this dark portion, let me increase the size so I can show you. When the when the water waves enter this section, here you can see the wave fronts, the distance between the wave fronts has decreased. In the deep water, you can see the distance between the consecutive wave fronts is larger. But in the shallow water, the distance between the wave fronts is smaller. It means the wavelength has decreased. We know that V is equals to F lambda. So let me write here. We know that the F frequency is equals to velocity uh, divided by wavelength. Okay? The frequency remains unchanged. The frequency remained unchanged. And from the figure, we know that the wavelength has decreased. The distance between the consecutive wavefronts is less, has decreased. So wavelength has decreased. The frequency is unchanged. The wavelength has decreased. Then the speed should also decrease to get the same value of the frequency, because F is equal to V by wavelength. So if the wavelength will decrease, frequency unchanged, then the speed has to decrease. So the speed will decrease. That's the reason.
Speed and wavelength are directly proportional to each other.
Don't use the word directly proportional, but yes, because the frequency has to be the constant here. And in the second portion where the water is shallow, the depth of the water is different in the second portion because the wavelength has decreased, so the speed should also decrease. Don't use the word directly proportional.
सर मैं पूछ
For
रही
your
हूँ कि अगर
understanding, you
वेवलेंथ
might think,
मैं पूछ रही हूँ कि अगर वेवलेंथ डिक्रीज होगी तो स्पीड भी डिक्रीज होगी.
हाँ जी ऐसा होता है बिल्कुल 100% this
Okay.
is the case. But don't use the word.
Okay, next part.
So what you wrote?
Wavelength of the wave decreases as it passes into right-hand section. Speed also decreases.
Because the F is supposed to be constant. That is the main reason. He says 1 mark for saying that the speed will decrease. 1 mark you will get. You said that the speed will decrease. Another mark is for why it will decrease. The wavelength decreases or refraction is towards normal, or I is greater than R, or top of the wave in shade region lags behind the bottom of the wave. The reason is because the wavelength has decreased. Okay?
सर
Kusum,
लिखो
read
कि
your
speed wavelength of wave decreases as it passes into right hand section. Speed also decreases because wavelength has decreased.
yes, that's the thing. So now you will get 2 marks. So we
Next.
are done with it. Now we are on the C part. It says figure 9.2 shows light in air striking the vertical side of a rectangular glass block at an angle of incidence of 60 degrees. The refractive index of the glass is 1.6. The light travels in the glass and strikes the side XY at P. Underline all the terms that describe a light wave. Light wave is electromagnetic and light waves are transverse. Okay? So you understand which terms you have to underline?
Transverse and electromagnetic.
Yes. So at the point where the light enters the glass, the angle of refraction is R. Calculate the angle R. Okay? So let's do that.
30.
Here. You are done with this.
Yes.
How?
Sir,
How you are
because
done with this?
the angle of incidence is 90 minus 60 and angle of incidence is equal to angle of no, I was telling wrong.
No. Yes. We know that the refractive index is equals to sine of I divided by sine of R. Just put the values in this. Refractive index is 1.6 equals to sine of 60 divided by sine of R. I want to find out sine of R. So sine of R is equals to 1.6 multiply sine, no, I went wrong. Here I have to write sine of 60 divided by 1.6. Just get the answer. So R will be equals to sine inverse of sine 60 divided by 1.6 bracket close. Just get the answer, G. Person get the answer, do the calculation. Sine 60 divided by 1.6 equals to, shift sine answer equals to. What is the answer?
Sir, why it is -1? Sine -1.
Sine inverse. I'm not writing -1. I'm writing sine raised to power -1. That means sine inverse.
Why it is inverse?
Because when the sine will go on the other side, it will become inverse. I want the value of the R. Not the sign R, I want the value of R.
37.5.
So you have to write this procedure, okay? This sine raised to power minus 1 means sine inverse. 37 point.
5.
Okay, so we are done with this. Let me check the answer. Our answers are good. They say the answer will be 33 degree. Sine 60 divided by 1.6 equals to. Shift sign answer equals to. So what you say? Kursam, recheck your calculation. You are saying 37 something, but this is calculation. The answer should come same.
Wait.
Let me open my own calculator. Okay, so we have sine 60. 60 and its sine. The sine 60 is 0.866. If I will divide it with 1.6, the answer will be 0.454. I will take the inverse of the sine. The answer is 32.76, which means 33. You see, I've done this calculator. I've done this calculation on the calculator. Recheck your calculation, bete.
Done.
What the answer you get now?
32.6.
How much?
32.6.
Okay, so when you round it off, it will be 33. Yeah. Okay. So the next question is, calculate the critical angle C for the light traveling in the block. You see, I want to calculate the critical angle. Very famous formula, N equals to 1 divided by sine of C. That's a very famous formula. N equals to 1 divided by sine C. I want to find out sine C. So this on the next line you will write sine of C equals to 1 divided by N. The value of the N is given to me. So sine of C equals to 1 divided by 1.6. So you do the calculation. So C equals to sine inverse bracket start 1 divided by 1.6. Kursam, do this calculation. I will also do this. So you see
30.6.
Yeah. So I have to 1 divided by 1.6. The answer is this, and then I have to find inverse sine of this thing. So it's something 38.68. What you said?
38.68.
So when you will round it off, so it will be
Yes.
39.
Okay,
So do you
39.
understand this?
Yes, sir.
Do you understand this? Huh? Okay, good. So
Yes,
we're done
sir.
this thing. Okay, let's go to the next part. At the point P, the angle theta between the ray and the normal is given by theta is equal to 90 minus r. State and explain what happens to the light when it strikes the side xy. So you just got the value. But first of all, let me check what Let me do this here. So the theta here, you know this theta? Oh, the theta here he's saying is 90 minus r. Okay, we will do that. Okay, so the theta is equals to theta is equals to 90 minus r. He's saying 90 minus r. Okay, we know the value of the 90 r. But what was the value of the r? 33. The value of the r was 33.
32.6. Yes,
33.
33.
Round it off. Okay. So 90 minus
Yes,
33.
sir.
What will be the answer? 90 minus 33. What will be the answer?
57.
57.
57.
So the okay. So you see, try to understand the angle of incidence here. Stop. The angle of incidence here is 57. The critical angle was 39. The angle of incidence here at the point P is 57 and its critical angle is only 39. So this angle of incidence is more than the critical angle. And you know that
Total
when the
internal
light is
reflection.
traveling in a dense medium, when the light is traveling in a dense medium and at the boundary of the dense medium and the rare medium, the angle of incidence in the dense medium, if it is more than the critical angle, the process of total internal reflection will take place. So at this point P, the light will be reflected. The total internal reflection will take place because at the point P, the angle of incidence at the boundary of a dense medium and a rare medium, the angle of incidence in the dense medium is more than the critical angle. The critical angle is 39, we just calculated in the previous part. So that's why the process of total internal refraction will take place and the light will be reflected back into the glass. For some, do you understand?
Yes.
Okay, let me take out the marking scheme as well. You can see it's a 2-mark question and the answer is in front of you also from the marking scheme. Ibete, have you written the answer?
Yes, sir.
Okay, so kindly
Total
read your
internal
answer.
reflection. Total internal reflection will take place when light strike XY side. Angle of incidence is 57 degree, that is greater than 33 critical angle. So light will be reflected.
Yes, it's right. Okay, you get the 2 marks. Question number 3 on your part number 3, I mean. On figure 9.2, draw the path of the light after it strikes the side XY at P and the path of the light when it is again traveling in the air. So let me take that diagram from here. Let me use the snipping tools. Well, let's copy it in the paint. Okay. Okay. Now, at the same, so I will draw. So the light will be reflected, and the angle of incidence
57 degree, or
okay.
reflection be 57 degrees.
This angle, this angle of reflection, sorry, this angle of reflection should be equals to this angle of incidence. Now, what will happen here? Here we will draw a normal. We'll draw normal. Now, check this angle of incidence. I will check what is the angle of incidence now. Here. If it is, because you will be working on that hard copy, I believe this angle will be less than 39. If this angle is less than 39, it will be 33 actually. I can tell you by my geometry skills. It will come out of the glass. But this time, when it will come out, because it's coming out of glass into air, it's coming from a dense medium into a rare medium. So it will bend away from the normal. So it will change its path. Okay, it will change its original path and it will move away from the normal. But do you understand?
Sir, 35. Angle of incidence 35 है.
Which is less than the critical. Na? The critical is 39. So the light will go out into
Yes.
the air. When it will go out into the air, it will be bended away from the normal because the light is entering from a dense medium into a rare medium.
अवे होगा तो फिर हमें उसकी वैल्यू फाइंड नहीं करनी कि किस एंगल ऑफ
No,
रिफ्लेक्शन.
you don't have to go into the calculation. By looking by the only the inspection of eye, it should be clear that the light has deviated from its original path and it has deviated away from the normal. You understand?
Yes.
Okay. So we are you are done with this thing?
Yes.
Okay. Okay,
Next.
now we are moving to the next question. Usam, you are saying something?
नो सर ये क्वेश्चन करते हैं.
Okay. So we are done with the question number 9. It says question number 10, two neutral atoms are atoms of different isotopes of the same element. State one similarity in the structure of these two atoms. What is the similarity between the isotopes?
प्रोटॉन नंबर सेम होगा.
They both have the same number of
मीन्स
protons.
इलेक्ट्रॉन
What's the
नंबर.
difference between the structure of these two atoms?
They will have different number of neutrons.
Okay. So they both will have same number of electrons and same number of protons. In electrons will be in outer shells, and the proton will be inside the nucleus. The difference is that they will have different number of protons. Okay, in the nucleus. Let us check. Let us check the answer. On your screen, you can see the marking scheme. Same number of protons or same number of electrons. That's one mark. And different number of neutrons. So we have written this answer.
Yes, sir.
Okay. So the B part is showing on your screen now. The isotope plutonium 239 decays by the emission of an alpha particle, symbol is shown also, to an isotope of uranium. The half-life for this decay is 2.4 expo 4 years. Complete the equation. Okay? You see?
इक्वेशन होगी U की 235, 92 नीचे आएगा और अल्फा का 4 और 2 होगा.
Okay. Let me copy it from here. Let me take it to the paint. Oof. I have, okay. So with the help of the pen, we take out the thing. Okay, alpha, its number here is 2, and here we write the 4. Okay, and so the uranium should have the 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 proton number should decrease by 2, so it should become 90. How much?
92.
I am writing with the mouse, so it's quite difficult to write. Okay, 92, and the mass number should decrease by 4. So here, which you should write 2.
235.
5. Okay, 235. You understand this
Yes,
better?
next.
Okay, next.
Yes, sir.
The count rate measured due to a pure sample of plutonium 239 is 64,000 counts per second. Calculate the count rate after a period of 1.25 into 10 raised per 5 years elapsed. What was the half-life? 2.4. Okay, let me do this calculation.
2.4 expo 4.
Yeah. Let me do this then. So the half-life, so how many half-lives will have passed? So first of all, I have to calculate that. Half-lives. That is 2.4 into 10 raised to power. What is the value? 10 raised to power how much?
4. 4.
So it's 10 raised to power 4. Okay. That's the
4.
half-life. So the total time which has passed, he has given us. What is that time? What is that time which he gave us?
1.2 expo 5.
1.2
1.2 expo 10 5.
So 1.2 expo 5 divided with 2.4. Yeah, 2.4 expo 5. Get the answer.
Expo 4.
This is Expo 4. Okay, just do the calculation. How many half-lives have passed?
Yes.
1.2 Expo 5 divided by 2.4 Expo 4. Get the answer. 1.2 Expo 5 divided 2.4 Expo 4. Get me the answer. Is this difficult? Okay, let me do myself. 1.2 divided by 2.4. What's the answer? Multiplied 10. 5
5.
half-lives have passed. 5. Now the question is, how many counts are left? Originally it was 6400. Okay, it's very simple formula. Remember this thing. 1 divided by 2 raised to power whatever is the number of half-lives. For example, the number of half-lives are 5. Okay. Multiply with the original
200
count.
sounds great.
6400. Just get this answer. 6400 divided by 2 raised to power 5.
200.
200. The answer is 200. 200 is the
Sir,
answer. I hope.
sir,
200. Yes.
सर हमें ये
Yes.
कैसे पता चला है कि हम लोगों ने ये हाफ लाइफ इस तरह फाइंड आउट करनी है डिवाइड करके?
The formula is 1 divided by 2 raised to power n. N is the number of half-lives. Multiply with the original count. That's the formula. Do you understand? Another way of doing this is, we can do this by another way also. So there are 5 half-lives. Okay. So at the start, it is 640. After 1 half-life, it will become 32 half. It becomes half. 3200. Another half-life, and it will become 1600. Another half-life, it will become 800. Another half-life, it will become 400. Another half-life, and it will become 200. You see, how many half-lives have passed? 1, 2, 3, 4, 5. So after 5 half-lives, there will be only 200 left. So this is how we do it. So this is how we do the third part. So my time of this lesson is over. And so I think we will continue this in the next time. So thank you very much, everybody. And have a good day. God bless you all. Thank you.